data in general, you start giving up a lot of things. One of them might be transactions. Right? Think, for example, you want to update file ID 0 and file ID 1 inside of a single transaction. They're living on different machines, so you have to do cross-database transactions there, which is a pretty difficult thing to do. Okay? You also do things when you start like this. You also give up the ability to be able to execute ad hoc queries efficiently. Okay? Imagine, for example, that we've sharded on file ID. Alright, so that means we know when we get a file ID in, we know exactly which shard it is. But imagine for each file if we had a file name associated with it. Okay? And a user wanted to search by file name. We do not know what shard that file lives on. So what we have to do in that case is contact every single shard, run a query against it to find out, hey, do you have this file name? Okay? So, we get some gains in terms of performance management, but when you start sharding, you start giving up a lot of things as well. And one other thing that you might give up as well is consistency. Yeah. So what you can do is you make a write. So you write one of your storage files to shard 0, and you write to the shard master. Okay. For some reason, our slaves are overworked, so we get a thing called replication lag, which means that writes that are written to our master are not replicated immediately to one of our slaves. And this is a problem that happens is when a game will write a storage file and then they'll read it immediately. And because these are behind time, we're going to get back the old storage file that we have. So again, what we're giving up there is we sacrificed some consistency. Okay? So I suppose the key point to take about this is that when you start moving towards scale, you have to give up some of the things that standard database systems take for granted.